Welcome to the tool demonstration of FixCheck, a Java tool for improving patch correctness analysis. The goal of FixCheck is to produce new fault revealing tests for potentially incorrect patches. There are two options to download FixCheck. One is by following the installation instructions on the README file, for which you will need at least Java 17 and Python 3.11. The second option is just to download the repository and then use Docker to build an image containing a working version of FixCheck. In both cases, you can follow the instructions that are provided in the README file in order to install the tool. In general, to analyze a patch using FixChecks, there are several steps that need to be performed. First, one needs to build the buggy version of the project corresponding to the patch under analysis. Then, one also needs to run an initial bug revealing test to collect its failing trace, which is an input to FixCheck. And then, one needs to apply the patch to the target project and build the patched version. From this point, one can execute FixCheck. So let's now illustrate the use of FixCheck with a concrete example. In this example, we will analyze a patch that was produced by an IPR tool as part of a previous study. The patch that we will analyze in this example is the following, and it is accessible in the defects repairing repository, which contains a dataset of several patches produced by IPR tools in order to solve bugs in the defects4j benchmark. In concrete, the patch that we will analyze addresses a bug in the Apache Commons Math project. So here I have installed a working version of a FixCheck. For the sake of simplicity and because the setup steps may be different for different patches, we will skip the execution of the setup in the demo, but all the steps for this specific patch that we are analyzing in this demo are available on the README file. So once the setup has been performed, we should have the target patch already applied in the target project and also the project built and compiled. To run FixCheck, we first need to make available an LLM, for instance, by running the following command. This command enables the replit code large language model and leaves it ready to be called by FixCheck. Once the model is available, we can run FixCheck with the following command. This command contains all the arguments to properly analyze our target patch. The class path contains FixCheck and all the dependencies in the directories in which the target patch was compiled. And among the arguments, we can see that we have the path to the test classes of the target project, the path to the source tests in the project. Also, we have the target test with the corresponding method. This is essentially the method that fails on the unpatched version, exposing the bug. And then among other inputs, we have the input type that FixCheck will use when generating new tests. We also have a file containing the failure trace of the given test that is going to be used by FixCheck to compare the failing trace of new generated test that also fails. And B, this argument contains the number of new tests to generate. And finally, this argument contains the LLM to be used by FixCheck, which needs to be consistent with the LLM previously initialized. During its execution, FixCheck will be showing the new test that it is creating. These are the new prefixes. And also, he will show the prompt that is using to call the large language model. FixCheck will also be reporting the response obtained from calling the LLM, which will hopefully contain assertions for the second test, which is the one that is the new test created by FixCheck. So FixCheck will then extract the assertions and proceed to execute the test with assertions and to categorize the test into a failing test or a passing test to be analyzed at the end. A few minutes later, FixCheck finishes and reports the number of generated tests and also the directories and files that it produced. The produced tests will be separated depending on whether they failed, they passed, or they didn't compile. Also, a ranking of the failing tests will be provided depending on the likelihood of revealing a defect in the patch. The higher the score, the more likely is that the test is revealing an error in the patch. For instance, here we can see the scores of the failing tests, and if we take a look at this test, which is the one with the higher score, we can see that this is the new test that FixCheck produced, revealing the defect in the patch, in which it differs from the initial for revealing test, in which in that it is trying with a matrix of different dimensions, which in this case is enough to trigger the bug in the patch. And that's it. We hope you have enjoyed this quick overview of FixCheck, and for more details, you can read our paper.